I'm Monishima Bentuan Ismail, matrix number 822800535. Firstly, I'm going to talk about the introduction of the report. The purpose of the report was to utilize descriptive statistics in order to organize and summarize the data by putting it into different groups. The aim of the study was to utilize a newly acquired statistical technique to provide a comprehensive depiction of the data and then conduct an analysis of the outcomes. The objective of the study was to provide students with knowledge regarding the calculation and assessment of measurements related to central tendency, variation, and position. For these studies, a dataset that included information on various species, fish prices from different countries, and multiple variables was available for the study. In order to fulfill the study's objective, we only utilized three factors such as place, price, and weight.
My name is Nur Ain Shahira binti Maknaha, number matric A22800452. Today I will present about central tendency, which is its mean, medians, and mode. Formula for means is sum of the product of mean, interval value, and their corresponding frequency divide total frequency. And for line 1, 1105.8 divided by 60, and the answer is 18.43, while for line 2 it is 1245.2 divided by 60, and the answer is 20.703. And for medians, the formula is the lower limit of medians class plus the number of observations divided 2 minus the cumulative frequency of the class preceding the median class divide the frequency of the median class multiply the size of the class interval. And for the line 1, 13.1 at 30 minus 17 divide 9 multiply 6 and get the answer 18.43. And for line 2, 20.1 at 30 divide 28 divide 24 multiply 6, and the answer is 20.39. And mode formula is a lower of the limit model class plus frequency of the model class divide frequency of the class preceding the model class minus frequency of the class preceding the model class multiply size of the class intervals. And for line 1 is 30.3 plus 3 divide 3 plus 3 multiply 6, and the answer is 16.1, while 2 is 20.1 plus 10 divide 10 plus 23 multiply 7 and get 22.221.
Hi and Assalamualaikum. My name is Nur Shazwina Alia binti Burhanuddin, matric number A22800468. So, I want to explain about measures of position. One of the measures of position is quartiles. The formula to find quartiles is: first, find the value of n by adding up all the frequencies. Second, calculate the less than cumulative frequencies for all class intervals. 3. Calculate the value of in divided by 4 in order to find the I for the quartile. For the quartile is contained in the class whose cumulative frequency is just greater than in divided by 4. 5. Calculate the value of the I quartile by using the formula given. So for the line 1, 13.3 plus 15 minus 7 divided by 20 multiplied by 6. We get 12.7, while length 2, 20.1 plus 15 minus 29 divided by 24 multiply with 7 and we get 12.7. For the measures of variation, there are three types of variation. First is standard deviation, second variance, and third range. For variance of length 1, we get 54.6166. And for the standard deviation, the answer we square root with 54.6166 and we get 7.3903. For the length 2, the variance we get 62.294. Then the standard deviation for the length 2, the answer we square root with 62.294 and we get 7.8926. For the range of length 1, we get 42.0 minus 7.5 and we get 34.5. While the length 2, 45.0 minus 8.4 and we get 36.6.
After that, the graphical representation. Graphical representation refers to the use of intuitive chart to clearly visualize and simplify data sets. Data is entered into graphing software and then represented by a variety of symbols such as line in a line chart, bars in a bar chart, or slice in a pie chart. This is the data for length 1. Figure 4.1 shows a histogram of the price for each fish. The y-axis displays the frequency of the data, which is the number of fish, while the x-axis displays the price of each fish using midpoint data. The highest frequency is 20 at the midpoint price of 19.6, while the lowest frequency is 1 at the midpoint price of 44. Next, graphical representation for length 2. Figure 4.2 shows a cumulative frequency graph or OGIF, which is a line graph that displays the cumulative frequency of each class at its upper class boundaries. The y-axis displays the cumulative frequency of the number of fish, and the x-axis displays the upper boundaries for the weight of fish in gram. As we can identify from the OGIF graph, the graph begins at 14.4 gram with the cumulative frequency at 0, and on the other hand, at the weight of 51 gram, the cumulative frequency is 60.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nurashikir binti Ibrahim and my metric number is A22A0315. I would like to present for the part 5.0, which is statistical analysis using software. For the table 1, is calculated by using SSPS. Variance for length 1 is 54.765 and standard deviation is 7.4004. While a variance and standard deviation by using manually is 54.617 and 7.3903. The difference of variance and standard deviation is negative 0.148 and negative 0.0101. Besides that, the variance and standard deviation for the line 2 by using SSPS is 63.268 and 7.9541, while by using manually for the line 2 is 62.294 and 7.8926. The difference that can shown is negative 0.974 and negative 0.0615. Thank you.
Next is hypothesis testing, which is here have 5 steps. Step 1, HO weight 1 equals to weight 2 equals to weight 3. HA weight 1 not equals to weight 2 not equals to weight 3. Step 2, set significant level A equals to 0.05. Step 3, as you can see the diagram below. Step 4, decision rule, reject HO significant below 0.05. Step 5, HA weight 1 not equals to weight 2, not equals to weight 3.
My name is Nur Amira binti Zaidi, metric number A22A0493. 5.3 Correlation Analysis. Research used Pearson product moment correlation to calculate the correlation analysis.
The Pearson correlation measures the direction and degree of linear, straight-line relationship between two variables. Based on the table shown, there is moderate positive correlation between length 1 and length 2. It was because the R equals 0.159. 5.4 Confidence interval. A confidence interval is a range of values within which the population parameter is expected to occur. The two confidence intervals that are used extensively 100%. Based on the data confidence interval table, the confidence interval can be related to 95% of confidence level. The SPSS results show that the standard deviation of the length 1 is dependent on 9.99%. The population parameter is between lower bound 24.68 and upper bound 27.81. Next, the confidence interval can be related to 95% of confidence level. The SPSS result shows that standard deviation of length 2 is dependent on 10.72%. The population parameter is between lower bound 26.737 and upper bound 30.094.
The prediction modeling, we use simple linear, which is y equal to BO plus B1 x1 plus B2 x2 plus error terms. Regression analysis using SPSS objective is to test the relationship between price, width, weight, height, length 1, length 2, and length 3. The diagram above shows price, width, weight, height, length 1, length 2, and length 3 scatter plots. A scatter plot is a metric. Metric is a grid or matrix of scatter plots that use dots to present values for two different numeric variables. Each scatter plot in the metric visualize the relationship between a pair of variables, allowing many relationships to be explored in one chart. In graph 1, there is a high level of association between price and width, price and weight, price and length 1, and price and length 2. There is no clear association between price and length 3. In graph 6, among the independent variables, there is a high level of association between width and height. As we can see, the R-square value is 0.972, which means 97.2% of the variation in price can be explained by width, weight, height, length 1, length 2, and length 3. The adjusted R-square is 96.9%, and the Durbin-Watson statistic is 1.979. In conclusion, this statistical assignment can teach us about description, data sampling, numerical descriptive, measurements, graphic representation, and statistical analysis using SPSS software. With 155 observations given a variety fish data set from different countries, we only use 60 samples with 7 selected variables, namely price, width, weight, height, length 1, length 2, and length 3 for numerical variables, species and place for categorical variables. With the data given using SPSS software, we can learn more about how to analyze and describe this data according to statistical calculations. In addition, we can also manually compare the calculation of this statistical data as learned in class with the data and calculation that have been analyzed in SPSS software. Next, be able to summarize, analyze, and interpret data into graph and result with population conclusion that have been made. Therefore, we can conclude that this assignment can help us statistically extract data for our own business or company use and improve the use skill and knowledge of business statistics that can be applied one day.